Hello again, Math 10Cs. In today's lesson, we're going to continue to look at using this equation in the form y equals mx plus b, which is referred to as the slope-intercept form of a linear equation. In the previous lesson, I think what we mostly did is we were given an equation in the form y equals mx plus b, and we had to use the equation to identify both the slope and the intercept. Most of the work in this lesson will kind of deal with the reverse process. So we'll have a graph, and then from that graph, we're going to have to determine specific information from the graph to figure out what the slope and the y-intercept is. Okay, so just as a quick recall here, so again, the equation is y is equal to mx plus b. In this equation, m represents the slope of the line, and then b represents the y-intercept. So that's a spot where the line crosses the y-axis. So let's go to this example. It says, write an equation of a line passing through the point 0, 2 with a slope of 5/2. Okay, so it flat out just tells us what the slope is. The slope is m, which is equal to 5/2. This point, it tells us what the value of y is when x equals 0. Well, that's your y-intercept. So your y-intercept would be equal to, we use the letter b to represent it. So this would be a y-intercept that's equal to 2. Now, to put it into the slope-intercept form, we have y is equal to mx plus b. And all I'm going to do here is I'm going to replace the variable m with 5/2 and the variable b with 2. So then you'd have y is equal to 5/2 multiplied by x plus the y-intercept of 2. So in the form y equals mx plus b, y equals 5/2 x plus 2. Okay, now this just flat out told you what the y-intercept and the slope was, in which case it was actually pretty easy to put it into the y equals mx plus b form. But I think this is more typical, where we actually have like a couple of lines on a graph, and then what we need to do is we need to collect information from the graph and put it into the y equals mx plus b format. Okay, so we have two lines here. So let's start off with this one. It says line 1, so I'll label that as L1. And again, I want to get it into the form y equals mx plus b, my slope-intercept form. So I need to get the y-intercept, which is easy to do. So if you look at line 1 here, let's just look to see where the graph actually crosses the y-axis. And the graph crosses the y-axis at this point right here. So this point would be, you'd have an x-coordinate of 0, and you'd have a y-coordinate of -4. Therefore, your b value would just be equal to -4. Now, to get the slope, we're going to have to draw a slope triangle. Well, you can do a slope triangle, or you can take any 2 points on the line and use the slope equation. But I think since we already have like the line on the graph, it's easier just to construct a slope triangle. Okay, so let's make a slope triangle. I'll do this in red. Okay, let's find a grid line intersection point to start off with. So it looks like about right here. Let's find another grid line intersection point somewhere over here. So I'm gonna go through these points I labeled. It's okay. Okay, so let's construct a slope triangle. And again, there's lots of different ways to construct slope triangles. This is not the only one that can be constructed. They'll all get the same slope. Now, on this slope triangle, let's label the rise. So the rise would be equal to, well, from left to right, we're going up by 1, 2, 3, 4 units. So I'll say the rise is +4. And the run is how many units the slope triangle goes across. And that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so let's go over here and calculate the slope now. So your slope, which is represented by the letter m, is equal to rise over run. And this would be equal to a rise, which is positive 4, divided by a run, which is 12. And if we reduce that fraction, divide the top and the bottom by 4, that would turn into a slope that is 1/3. Now, to write it in y equals mx plus b format, we're just going to replace m with 1/3 and b with -4. So then the equation of that line would be y is equal to 1/3 x, and replace b with -4. Okay, so that's the equation of line number 1. So y equals mx plus b. So the slope is 1/3, positive 1/3 because you're going up, and the y-intercept is -4. Now let's go to line number 2. So we have L2. Okay, so first of all, let's identify what the y-intercept is. So the y-intercept is at this point. So this point would be an x-coordinate of 0 and a y-coordinate of 2. So your y-intercept, which we use the letter b to represent, would just be a value of positive 2. Now let's go ahead and draw a slope triangle to calculate the slope. Okay, so let's figure out where we have some endpoints here. I think this is an endpoint right here. It's hard to see because I circled it. And then let's go all the way down, actually just to the y-intercept. And again, you can choose wherever you want in this line to draw your slope triangles. Just try to look for grid line intersection points to start and stop your slope triangle. Okay, so we'll go down here, and then we'll go straight across. So your rise would be equal to, now from left to right, we're going down. So your rise is going to be a negative number. And we're going to go down by 1, 2, 3, 4, 5, and 6. That's going to be a rise of -6. And then your run is how far we go across. We go across by 1, 2, 3, and 4. So if I calculate my slope, slope is rise over run. And again, if you wanted to, you could just take 2 points on the line and use the y2 minus y1 over x2 minus x1 formula. Whichever method you prefer is totally acceptable here. Okay, so your rise would be -6, and your run would be +4. If you reduce that fraction by dividing the top and the bottom by 2, you get -3/2. And then to turn this into the y equals mx plus b format, so you'd have y is equal to, let's replace m with -3/2. And then b, the y-intercept was 3/2x plus 2. So y equals m, which is -3/2x, plus b, which is a value of 2. So those are the equations of my straight lines. Okay, let's go down to something a bit more complicated. Okay, it says determine the equation of the following lines. So we want a line that is parallel to, so I'm going to label this. Let's say we're going to figure out the equation of a line that I'm going to call L1. That's parallel to this line, which I'll call L2. And it has the same y-intercept as this equation, which is L3. Okay, so here's what we need to look at. So for my line L1, it says the line I'm going to write an equation as must have this, it is parallel to this line right here. Okay, now for this line, your slope is 1/3. And the slope of lines or line segments that are parallel are the exact same slope. So maybe what I could say right here is I could say the slope for line 1 would be equal to the slope for line 2 if parallel. Therefore, the slope for line 1, so we can call that M1, or I can just change it to M, would be equal to well, here's my slope. Y equals mx plus b. So the slope of this line would be 1/3. Now it says the line we're going to write an equation for also has the same y-intercept as this line. Okay, so I could say the y-intercept of line 1 would be equal to the y-intercept of line 3. And the y-intercept of line 3 is just -7. Now, to write my equation down, so this would just be the value of b. So again, put it into the equation y equals mx plus b form. So y equals mx plus b. So for my line 1 would have a slope that's 1/3 because it's parallel to line 2. Parallel slopes have the same, line segments have the same slope. So 1/3 x. And then it has the same y-intercept as this equation. The y-intercept of this equation was -7. So in the place of b, we're going to write down -7. So the equation of this line would be 1/3x minus 7. Okay, b says let's get an equation of a line that passes through the point 0, 9. So right away for here, passing through 0, 9, that's the y-intercept. So your y-intercept would be b is equal to 9. So if our line passes through this point, its y-intercept must be 9. So I know the b part of the equation. Okay, now it says the line we're going to look at. So we'll say the line that we're going to write the equation for, I'm going to call L1, is perpendicular to this line, a line that joins together these points here. Okay, so these points are going to form the slope of line number 2. So what I'm going to do is I'm going to calculate the slope of line number 2, and then we'll figure out what the perpendicular slope is and for our line number 1, and then we'll write the equation out. Okay, so let's figure out what the slope of line number 2 is. So I'll write down the slope of line number 2. So m of L2 would be equal to, now it gives points here, so it's much more convenient just to use the endpoint formula. So what I'm going to do in this equation is I'm going to say that, let's just label this. So we're going to call this point x1. We'll call this y1. We'll call this x2. We'll call this point y2. Okay, so let's write down our slope formula. So the slope of line 2 would be y2 minus y1 divided by x2 subtract x1. Let's plug these numbers in. Okay, so y2, the y coordinate of this point 2 is 0. Subtract the y coordinate of point 1 is -6. Divide by x2, which has a coordinate of -5. And then subtract x1, which has a coordinate of +2. Okay, so 0 subtract -6 would be +6. Negative minus a negative is a positive. And then -5 minus 2 would be -7. I'm just going to rewrite it a little bit though. Generally, we like to write the negative on the top. So instead of writing 6/-7, I'm just going to write down -6/7. Okay, now the line we're trying to write the slope for is perpendicular to the slope of this line. Okay, so I'm going to say if, we'll say if line 1 okay, if L1 is perpendicular, and here's a symbol for perpendicular, draw a couple of lines and a little square between them. If line 1 is perpendicular to line 2, then the slope of line number 1 would be equal to, okay, so how do the slopes of perpendicular line segments compare? If you take the slopes of two perpendicular line segments and multiply them together, they have to be equal to -1. The only way you can get that is by taking the reciprocal of the slope and the negative reciprocal. So I'm going to take the negative reciprocal of -6/7. So that's going to turn the negative to a positive, and it's going to flip the slope to 7/6. Okay, so if the slope of line segment of line 2 is -6/7, then the slope of line 1 would be the negative reciprocal, which is 7/6. Okay, and that's going to be equal to the slope value m I'm going to write for my equation. Okay, so now we can write the equation out. So then we would have, you'd have y equals mx plus b. So again, that's my slope-intercept form of an equation. Then y would be equal to, okay, the slope of line 1 would be that negative reciprocal of this one. So that's going to be 7/6 x. And then the y-intercept we identified up here, because it has to pass through that point, it has to have a y-intercept of 9. So you'd have 7/6x plus 9. So that is my equation of a line that would have a y-intercept of 9, which passes through the point 0 and 9, and is perpendicular to a line that connects these 2 points. Okay, let's go to the next page. It says the diagram on the right shows the display from a graphing calculator screen. The intercepts are integers. Determine the equation of the line shown. Okay, now we gotta be careful with like the grid lines here. So I can see like a few grid lines on this diagram. Now these grid lines do not go up by 1. To figure out what these grid lines go up by, we need to look at the x scale. Okay. So what it tells me here is the x scale is telling you how much each one of these grid lines goes up by. So each one of these grid lines would be going up by 5. So this would be 5, this would be 10, this would be 15, this would be 20, this would be 25, and this would be 30. And then for the y-axis, these aren't going up by 1s. If we look at the y scale, which is this one, it tells me that we go up by 7s. So this would be 7, and this would be 14. Okay, so what we want to do is we want to figure out what the equation of this line is. Again, to do that, we can just first of all just look directly at the graph and look at what the y-intercept is. So if I look at the graph here, your y-intercept would be at this point, okay? So that point would have coordinates of 0, 14. Therefore, your y-intercept b would just be equal to 14. Now, we also need to get the slope. So to get the value of m, so if I draw a slope triangle, okay, so on this slope triangle, the run would be equal to, okay, we're going across by 5, 10, 15, and 20. So your run would actually be 20 if you implement the correct x scale. And then the rise here would be, well, you're going from 0 all the way up to 4. You're going from 14 down to 0. We have a descending slope here. So this would be a rise that is going to be negative, and it's going to be -14. Okay, we start at 14 and we drop all the way down to 0. Okay, so let's calculate the slope. So slope is equal to rise over run. The rise would be -14, and the run would be +20. We can reduce this fraction by dividing the top and the bottom by 2. So 14 divided by 2, -14 divided by 2 would be -7, then 20 divided by 2 would be 10. Okay, and then we just put it into the form y equals mx plus b. So again, that's my slope-intercept form, y equals mx plus b. Then the equation of this line would then be negative. So the slope is -7/10 x, and then plus the y-intercept of 14. Now, if you want to double check that you did this correctly, what you could do is you could go to your window settings in the calculator and turn them to these exact window settings. And then you could plot into the y equals function. For y1, I would plug in -7 over 10 x plus 14. It'll plot a graph, and it should look exactly like what you see in the picture here. Okay, so that'd be a way of confirming that you did that correctly. Okay, we're going to come back to, so we dealt with lines that have slopes to it. Now we're going to come back to dealing with horizontal and vertical lines and looking at the equations of them. We already looked at in the previous unit what the slope of horizontal and vertical lines are, but now what are the equations going to be? All right, so it says state the slope and the y-intercept of the horizontal line L1 shown on the grid. Okay, so if you look at L1, first of all, the y-intercept would be at 0, 4. So my value of b would be equal to 4. Now, for a horizontal line segment, if you try to calculate the slope, so you want slope is equal to rise over run, the rise of a horizontal line segment is 0. Okay, it doesn't go up or down at all. Regardless of what kind of a run you have, 0 divided by any number for a run is going to be equal to 0. So the slope of like a horizontal line segment is 0, which means that the line is just completely flat. Okay, so let's see what happens if we actually wrote this in y equals mx plus b format. So if we have y equals mx plus b, this would be y is equal to, well, m, you have a slope of 0 times x plus 4. 0 times x would be equal to 0. So this would be equal to 0 plus 4, which would actually tell you that the equation of the line is just y is equal to 4. Okay, so in the y equals mx plus b part of the equation, the mx part just cancels off because the slope is 0. Now, this equation actually makes a lot of sense because what it's telling you is a line that has y equal to 4, it means that everywhere on the line, your y value is 4. So for example, if we're at a value of x equals 0, the y value is 4. If we're at an x value of 5, the y value is 4. If we're at an x value of -5, the y value is 4. So it doesn't matter where you are along the line, the y value is always equal to 4. Okay, so then it says for C, predict the equation of the horizontal line L2. Okay, so the way to write the equation of a horizontal line is just simply write y equals and then identify what is always the value of y. Well, in this line here, it hits the y-axis at 0, -6. So it doesn't matter where you go left or right, the value of y would be equal to -6. So you have y is equal to -6. That's your equation. Now, if you want to confirm that was correct, you could put it into your graphing calculator, and all you would simply do is you just plug in y1 is equal to 6. Not 6, -6. And then if you did that, you would get the horizontal line. Okay, so if you want to confirm that, you can go ahead, but I'm not going to show it right here. Okay, now this gets a little bit tougher now. So now we're going to deal with like some vertical lines. Okay, so it says D, state the slope and the y-intercept of the vertical line L3 shown on the graph. Okay, so first of all, if you look at the graph here, there is no y-intercept. This line never actually touches the y-axis. So I could say there is no y-intercept. Now there's an x-intercept, but we'll deal with that in a second. But there is no y-intercept. The line does not cross the y-axis. Now, as for the slope, again, you'll recall in the previous unit, if we have like a vertical line, it'd be like climbing like a vertical wall. And what's the height of a vertical wall? Well, you can think of it as being kind of like infinite. But the way we described in that previous unit is we said that the slope was undefined. So again, in a sense, thinking of undefined means that your slope would be like infinitely large. And again, that's what a slope of like scaling a vertical line would be. Okay, so there is no y-intercept and the slope is undefined. Now it says, why can we not use the form y equals mx plus b to determine the equation of the vertical line L3? Well, because first of all, you don't have a y-intercept, and then secondly, the slope is undefined. So like, what value would you plug in for m? Like, I guess you could plug in like infinity, but that wouldn't really give you like an actual equation. It'd be an equation that's not really useful. Okay, so why can't we use this form? I would say because the slope is undefined. If the slope is undefined, you can't plug it into a defined equation like y equals mx plus b, and there is no y-intercept. Okay, now it says, predict the equation of the vertical line L3. Okay, now this is kind of similar to how we got the equation of these horizontal lines. So for these horizontal lines, we had one value that was always the same number. For L1, my y value, no matter what, was always equal to 4. Therefore, my equation is y equals 4. For L2, no matter what you do on the line, your y value is always equal to -6. Therefore, the equation is y equals -6. Well, how about L3? What's the one number that would always be the same no matter where you are on this line? Well, that would actually be the x value. So if you look at the graph here, this line would cross the x-axis at -3, 0. So it doesn't matter where you go on the graph, whether you're at the top of this line or at the very bottom of this line, the x value would always be -3. So when y is 5, the x value is -3. When y is 0, the x value is -3. When y is -6, the x value is -3. So no matter what, it's always -3, the x value. Therefore, the equation we could write here is we could just say x is equal to -3. Again, because it's telling you no matter where you are in that vertical line, the value of x is always -3. Now it says here, why can we not use a graphing calculator to verify this? Well, here's the problem. The graphing calculator is not set up to plot equations where you have x is equal to. The graphing calculator is only set up to plot equations in the form y equals not x equals. Okay, so you cannot use your graphing calculator. There might be a workaround way to do it, but the way that the calculator is generally set up, there's not really a way that we can actually plot that. Okay, because the graphing calculator plots y equals, it does not plot x equals. Okay, last example says determine the equation of the line that passes through the point -2, 8 and is parallel to the y-axis and or is parallel to the x-axis. Okay, so first of all, in this ordered pair here, this is the ordered pair, x, y. Okay, now it says, write the equation of a line that passes through this point and is parallel to the y-axis. Well, maybe we could sketch a little grid just to kind of like see what this would look like. So I'll draw like a little x and y axis. So we're going to focus a lot in quadrant number 3 here. So we'll say this is the y-axis, and we'll say this is the x-axis. Okay, maybe we could label some points here. So we could say like here's 1, 2, so 2 to the left, and then 1, 2, 3, 4, 5, 6, 7, 8. So my point of interest here would be located at -2, 8, which is going to be up here. Okay, now it says, for the first part, what I want to do is I want to determine the equation of a line that passes through this point and is also parallel to the y-axis. Now, parallel to the y-axis would mean that you'd have to have a vertical line. So if I sketched a vertical line here, so I'll just go ahead and quickly grab one. I'll do it in maybe like green. Okay, so this would be a line. Okay, obviously I didn't do the greatest job of getting that to go through my point. Okay, we'll say that's about the point there. Okay, so that would be a vertical line that passes through the point -2, 8. Okay, so to write the equation of a vertical line, you just have to identify, well, what's the one value that's constant? And if you look at the line here, it doesn't matter where you go along the line, the one value that's constant is your value of x. And what's the value of x always going to be equal to? Doesn't matter where you are along the line here, the value of x would be equal to -2. So my equation of that vertical line would just be x is equal to -2. Now for b, it says draw a line that's parallel to the x-axis and passes through that point. Okay, so we'll go ahead and grab a line. This time I'll do it in red. Okay, so parallel to the x-axis must be a horizontal line. So that's going to be a line that looks something like this. For a horizontal line, again, try to identify what's the one value that's going to be constant no matter where you are on the line. Now, no matter where I'm on the line, whether I'm all the way over to the left or all the way over to the right, the one thing that is constant is the value of y on the line. So the equation of this line would just be y is equal to +8. Okay, parallel to the x-axis must be a horizontal line, and then all values of y on the horizontal line are y equals 8. So it's one thing to be aware of. If you're drawing vertical lines have an equation that starts with x equals, and vertical lines have an equation with x equals to start off with, and horizontal lines always have an equation of y is equal to start the equation off with. Okay, so that's it for this lesson, and you can actually complete numbers 1 through 9. And I will talk to you in the next lesson.